Hey guys, this video is to intro the activity that we're doing to find the angle sum, the interior angle sum of any polygon. What that means is if you take any polygon, we have a triangle here, quadrilateral, true for pentagon, hexagon, a 20gon, which is a 20-sided polygon, a 52gon, any kind of polygon, we can actually find out what the interior angle sum would be, meaning like if you added up all the angles, the angles inside the polygon, if you added them all up, what would their sum be? So what we're going to do for this activity is use the fact that we should know by now that the interior angle sum of a triangle is 180 degrees. And using that fact, we're going to take polygons that have more sides in a triangle, like a quadrilateral or a pentagon, hexagon, or whatever, and see how we can break these polygons into multiple triangles and use the fact that the angles in a triangle add up to 180. Okay, so what I mean by that is this. Since we know that these three angles in this triangle add up to 180 degrees, so like if I call this angle 1, this angle 2, and say this angle 3, if we added up angle 1, the measure of angle 1, meaning its actual angle value, plus the measure of angle 2, plus the measure of angle 3, it's going to equal the sum of 180. That's a fact that we need to know. So here's the process that we're going to do for any polygon to break it into triangles to use this fact. We're going to draw the diagonals from one vertex of the polygon and draw as many diagonals that we can. So if you look at this quadrilateral over here, we have three vertices, or four vertices. So pick one of them. It doesn't matter which corner or which vertex we choose. I'll use point F. So a diagonal is a segment that connects non-adjacent points. Adjacent means next to. So point E is next to F, right? And if we were to connect those, that's just the side of the quadrilateral. Point G is adjacent to F2, and again, if we were to draw the segment, that would be the side. But D is not next to F, and this segment that connects D and F is what we call a diagonal. And notice when you do a diagonal, and it doesn't matter which one I chose, we could have went E to G, but it takes our quadrilateral and it breaks it into two triangles, right? So what we can look at this is, let's look at this upper triangle here. I'm going to call this angle 1, this one angle 2, and this angle 3. So we should know in this triangle, if we add up all three angles, we get a sum of 180 degrees. So we know that these add up to 180 also. Okay, now let's look at this lower triangle down here. Same deal. I'm going to call this angle, say 4, because I'm already using 1, 2, and 3. This will be 5, and this will be 6, right? And we know that this lower triangle, if we add up angles 4, 5, and 6, that they're going to equal a sum also of 180 degrees, right? So now if you think about it, back to the four angles in this quadrilateral, this angle E, which we're calling angle 1, plus angle D, which we're calling 2 and 4, right? The sum of 2 and 4 is really this angle D of the quadrilateral. This angle 3 and angle 5 together make this angle F of our quadrilateral, and our angle 6 is also our fourth angle of the quadrilateral. So if we added up angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6, it really is going to equal the four angles in our polygon, in our quadrilateral, which then should just be the sum of our 280 degrees, which 180 plus 180 makes 360 degrees. So we took a quadrilateral, we picked a point, like F, and I drew as many diagonals as I could. In a quadrilateral, there's only one diagonal in there from this one point F, so it broke our quadrilateral into two triangles, and then we know the fact that each triangle has an angle sum of 180, so then we just took 180 plus 180, or you could think of it as 2 times 180, since there's two triangles, and we get an angle sum of 360, okay? Let me grab a tool here and make a octagon, for example. So here's an octagon. Here's our process again, just so that you can understand this, I hope. We're going to pick a point, and draw as many diagonals as you can. So I'll pick this point right here. So the first diagonal, again, these are adjacent, that's a side. So here's my first diagonal, second diagonal, third diagonal, fourth diagonal, and in this octagon I can actually make 5 diagonals, right? So in here we have one triangle, the 3 angles here add up to 180, the 3 angles in this triangle add up to 180, these add up to 180, 180, 180, 180. So we could actually figure out the angle sum of an octagon by just saying that we actually created 1, 2, 3, 4, 5, 6 triangles based off of our little technique here of drawing diagonals from one vertex. So we know that this would be, since there's 6 triangles and the angle sums are 180 each, this angle sum would be like 6 times 180 degrees, right? So that could be the angle sum. All right, so that's the process that we're going to use as we go to fill out this table right here. So what I want you to do is make sure that you have this packet here. If you don't have one, get one from me. But you're going to answer these first 4 questions on the first page. And then where it says Part 1 Investigation, this is exactly what we just talked about. And for some reason on my video here, my Word document's all messed up, but yours isn't. This Part 1 talks about exactly what I just went over here in the last 6 minutes, but it has a lot of math symbols in it, right? So the measure of angle 2, this is just talking about like the angle value. So if you took the angle value of angle 1 plus the angle value of angle 2 plus the angle value of angle 3 based off this picture, they should equal, 180 degrees and so forth. So fill out this page. This right here, this procedure, is actually explaining what I just covered there, right? So answer this question here at the end, and actually this shouldn't be triangle right here. We can think of it as, when you know the number of triangles formed, how do you find the sum of the interior angles of the, and we're going to say polygon instead of triangle. So fix that, please. So answer that question. Then you're going to go to the third page. This is really what I want you to do. You're going to actually fill out this table where you draw the polygon, you sketch a little picture of the polygon, you record how many sides the polygon has, and then you figure out how many diagonals you can draw from one vertex, the number of triangles formed, and therefore you could figure out the angle sum based off the number of triangles. Okay, so answer the questions at the bottom of this page, finish Part 1, and this next video that I have in this quest will explain the next part of our activity. Okay, good luck, guys.